This question comes from Dennis. If the Earth's average radius increased by 1 centimeter every second, how long would it take for people to notice their weight gain, assuming the Earth's rock composition remains the same? Imagine the entire Earth from its core to its crust expanding uniformly beneath our structures, which remain unchanged. To prevent an ocean drain scenario, let's assume the oceans expand as well. When the expansion begins, you'd feel a slight jolt, as if being gently lifted. After that, you'd be rising at a steady rate of 1 centimeter per second without feeling any ongoing acceleration. By the end of the day, you wouldn't notice much of a difference, but the Earth's radius would have grown by 864 meters. It would take a long time for gravity to change noticeably. If you weighed 70 kilograms when the expansion began, you'd weigh just 70.01 kilograms by the end of the first day. But how quickly would our roads and bridges start failing? Surprisingly, not as fast as you might think. Here's a classic puzzle. Imagine tying a rope snugly around the Earth, so it just touches the surface all the way around. Now, if you wanted to raise the rope by 1 meter, how much extra length would you need to add? Miles? Hundreds of miles? No, just 6 meters. Circumference is proportional to radius, so if you increase the radius by 1 unit, you increase the circumference by 2 units. After 1 day, the Earth's 4,000 kilometer circumference would increase by 2 times 864 meters, about 5.4 kilometers, or just 0.01%. Virtually all structures could easily handle this, as concrete expands and contracts by more than that daily. The first major disruption would come from GPS satellites. They would remain in their original orbits while the Earth expanded, causing precise synchronization between ground stations and satellites to fail within hours. By the end of a month, Earth's radius would have increased by 26 kilometers, leading to a 0.4% increase in surface gravity. But even though Earth's mass would have increased by 1.2%, the increase in gravity would be minimal since you'd also be further from the center. This weight difference would be too small to register on a scale, as human body weight fluctuates more than 0.4% throughout the day. What would be noticeable, however, is the expansion itself. Cracks would start forming in long concrete structures. Elevated roads and old bridges would begin to fail. Most buildings would remain intact, though those anchored to bedrock might start behaving unpredictably. After a year, gravity would be 5% stronger, and the ground beneath structures would have expanded by 5%. You'd probably start noticing your weight gain, and infrastructure failures. Roads, bridges, power lines, satellites, and undersea cables would become widespread. A precise pendulum clock would now be 5 days ahead. After 5 years, gravity would be 25% stronger. If you weighed 70 kilograms at the start, you now weigh 88 kilograms. Most infrastructure would have collapsed, not due to increased gravity, but because the ground expanded by 25%. Surprisingly, skyscrapers would remain standing, as they're designed to resist forces like wind rather than weight increases. After 10 years, gravity would be 50% stronger. We assume the atmosphere expands as well. Otherwise, the air would be too thin to breathe. With an expanding atmosphere, air pressure would increase due to both gravity and more air, but survival would still be possible, at least for now. After 40 years, Earth's surface gravity would have tripled. At this point, even the strongest humans would struggle to walk. Breathing thick air would be a challenge, trees would collapse, and crops would be unable to support their own weight. After 100 years, we'd be experiencing over 6 times Earth's original gravity. Moving around would be impossible, and even our hearts wouldn't be able to pump blood to our brains. Only small insects and marine creatures would be able to move. Worse yet, at some point, atmospheric oxygen would become toxic due to increased pressure. Perhaps humans could survive inside controlled pressure chambers, lying horizontally while being tended to by robots, but this would be the end of our civilization. Would Earth eventually become a black hole? That's difficult to say, as Dennis's premise assumes the radius keeps expanding while the density remains constant. However, forming a black hole requires increasing density, not just mass. In reality, as more mass accumulates, the stress would exceed the strength of chemical bonds, causing the Earth to collapse inward. It would shrink into a sputtering white dwarf star, held up by electron degeneracy pressure. Then, after around 1,500 years of continued expansion, if the mass kept increasing at the same rate, Earth would surpass the Chandrasekhar limit for white dwarfs, and finally become a black hole. But before that happens, it's a shame humans wouldn't survive long enough to witness an incredible event around year 300. As the Earth expands, the Moon, like our satellites, would gradually spiral inward. After centuries, it would be close enough that Earth's tidal forces would overpower the Moon's own gravity. Once the Moon crosses the Roche limit, it would gradually break apart, and for a brief period, Earth would have a spectacular ring system just like Saturn. So, would people notice their weight gain? Not immediately, but as the years passed, the expanding Earth would bring destruction long before anyone worried about their extra kilograms. And in the distant future, our growing world would end as an unimaginable cosmic event, a black hole swallowing everything in its grasp. If you enjoyed this story, make sure to like this video, it really helps us out. Share it with friends who'd love to learn something new, and subscribe to the channel for more fascinating content like this. Don't forget to turn on notifications so you never miss an update. Thanks for watching, and I'll see you in the next one.